Okay, now going to the walked example, I'm just going to show an example with question number one of the summary questions, and then I will leave you to do the rest. And I would like you to, just like I'm showing you my own worked example here, I would like to see you sharing your work. So what I would suggest that you do is that you then do questions 2, 3, and 4, show your steps, take the picture, and send it back to me. Okay. Question 1 reads, a vehicle is traveling at a speed of 18 meters per second. So the initial speed would then be 18 meters per second, which is u, on a level road. So if I want to represent that, I would then say, that is the vehicle and that is the level road. So when the driver sees a pedestrian, obviously somebody there, stepping up the pavement into the road 45 meters away, so from that spot to that spot is 45 meters away. Okay, the driver reacts within 0.5 seconds, so we can then say the reaction time of the driver is 0.4 seconds, and he then applies the brake. So the reaction time will then take the driver through a thinking distance, okay, in 0.4 seconds. Okay, so we then have the car then decelerate at 4.8 meters per second. So from here to here, the deceleration is minus 4.8 meters per second squared. So that will be the deceleration. So we're now asked to calculate one, the thinking distance. And from our previous generalization, our thinking distance, because it's traveling at this velocity u here and it has time, so we're just going to say that u is thinking distance over time. Therefore, thinking distance is u times time, and that will be what is our u? 18 meters per second times our time, which is 0.4 seconds. So, and if we use our calculator, that gives us 18 times 0.4, that gives us 7.2 meters. That will be the thinking distance. So from here to here will be 7.2. So we still have some distance to go. So let's now work out what is the next challenge, the braking distance. Our braking distance, as we have seen in our previous clip, is going to be S equals u squared over 2a, and that is already worked out in our previous slide. Basically, we're saying that if u is the initial velocity, final velocity when it stops will be 0, and therefore using v squared equals u squared plus 2as becomes 0 equals that, and then from there you can actually resolve this. So just to save time, so our braking distance would then be, what's our u squared? Our u squared is 18 squared divided by 2 times 4.8, and that's it. So we're going to have approximately, what is it? Let's use our calculator. 18 squared divided by 2 divided by 4.8 would then give us 3.375, that is 33.75 meters. So obviously if you add this to 7.2, so which is approximately 33.8, so if you add that plus 7.2, that should give you a total of 41 meters. So the next question is, how far does the driver stop from where the pedestrian stepped into the road? That would then be 45 minus 7.2 plus 33.8. So 33.8 plus 7.2 is 41. So that leaves you with 4 meters. And that is how you do question 1. I hope that is clear and everybody can see it. So, and I hope this video captures it. So you do the rest now. We're going to be back in about 15 minutes, and I would like you to turn in your work.